everybody missed the fact that under all the diagrams that you saw, there is silicon. Under all the diagrams, there is silicon. So I think Yogesh and Priya thought that we should open this window going forward, because in that stack, the stack just became bigger and deeper. So in this conversation, we'll be listening to people who've been in that underground space, doing work on silicon, on which everything else rests. We've been busy on the upper nanosphere, should we say. So the idea of this panel essentially is that there's more going on underneath all of the software and data, and that more is actually beginning to happen in India at a fast pace. The whole new manufacturing, semiconductor, the whole buzz around that is becoming real as India looks at Atmanirbhar Bharat and so on, all of those initiatives. And we thought we should now expose the group to what's happening in that space on the very simple premise that just like we looked at integrating everything together in all the conversations, we have to integrate vertically as well. So, and then the implications of that in terms of what does it mean, not just for people in this room, but what does it mean for all the people involved in the game of building talent for the industry going forward, if this whole comprehensive integration has to happen. So my panelists have been introduced, but the answers will tell us more than what the titles are. And essentially we want to get a better sense of what will it take for India to realize the potential of the integration of the full stack, from silicon to systems. And what are the relevant questions? We've talked about scalability, we've talked of efficiency, we've talked of sustainability, but we apply that to the overall context. So what I want to start with, and Venkatesh with you, is this whole talk about semiconductors in India, and we said we can't make them, we can't have fab, we can't have whatever, but suddenly things are changing very rapidly. So first of all, what is changing and what's driving the change which is making this lower structure become real in India?
Well, India has always been a source of semiconductor talent. I remember back in 1992, I was attending a VLSI design conference here in Bangalore, in Taj Residency. There was an invited paper on a topic called the contribution of Indians to the field of testability. Testability being one of the areas in semiconductor design. From that point onwards, things have actually gone upwards and upwards. Today, according to NIIT, 20% of all semiconductor engineers in the world are in India. And we semiconductor companies feel it's not enough. Now we have all of this talent. And the other big fact is that India is one of the fastest growing markets for electronics. We consume a lot, $250 billion worth in the last 1 year, depending on the sectors you look at it. And we're importing a lot, to $90 billion of imports. Now, when you have talent and then you have a market, we expect some magic to happen. The magic being to conceive of products, to build the product, design the products, manufacture the product and deliver it here. We are not completely there yet. And why not? So when we look at the talent, we can write software. It is a server-side software, device-side software, we are very good at it. We are pro on ourselves. Then if you go one layer below, we have the hardware. We can build the PCBs, we can build the electronics, we can manufacture the electronics. You know that majority of the phones that we buy in India are manufactured in India now, because of all of this. So we can do all of that. When you go one level below, we hit bedrock. And that bedrock is the semiconductor chip. Inside the chip, there is so much functionality that is making all of this happen. Traditionally, chips have come first, and then other things have come. Back in the late 80s, I was writing expert systems, the forerunner of artificial intelligence. Never went anywhere because the processing power was not there. Today, every new step is powered by semiconductors. And what are we lacking as talent in order to develop that here? First one is that although we have a lot of companies here outsourcing work here, doing work here, the semiconductor manufacturing has not yet established a presence in India. Manufacturing companies don't have large number of employees here. So the processes involved, the machinery, the tools, the techniques, and how to get better yield, that work has not happened. We don't have enough expertise there. The second expertise we lack is to build a successful semicon company, we need alliances, we need infrastructure, we need partnerships, okay, which Silicon Valley is full of that thought process, the strategic thought process, strategic way of creating an ecosystem in order to make something successful. That is also something we lack, and going ahead, I think we will add that.
So quite clearly the subterranean stuff has to come up, and I think good that you indicate that such a large number of people, the engineers, 20% are working on that. And we see that the GCCs is a very good expression of the movement of that talent and that workloads to this part of the world. And therefore the underlying phenomena is happening, though it's restricted not restricted, largely in the GCCs, who are the back offices of the people who are conceptualizing these designs. Now, we also know that the big challenge is coming because of the workload that AI and ML is imposing even on those designs. So, Sundeep, the question for you I have is that GPUs arrived on the scene, we know by accident. I mean, NVIDIA wasn't designed for it, but it was doing graphical processing. And when we moved from data into images and language, which is the big jump of Gen AI, suddenly it became possible to use what was intended for a different application for here. And maybe that's good enough to see the workloads as we understand them now. But when you look at the workloads of the future, what will we have to do? What kind of needs it will throw up in terms of GPU plus requirements, and what kind of underlying skills, capabilities beyond what even our GCC bright engineers have?
So, yeah, as you rightly said, NVIDIA got extremely lucky with GPUs being the perfect choice for AI workloads. But as we've seen in the talk right now and the earlier talks as well, there are n number of different applications. And what NVIDIA is doing today is one size fits all. So you have the underlying NVIDIA GPUs. By the way, so there's a new term now what we call as XPUs. So X can be anything, right? So it's not just GPUs. And what we are moving towards are bespoke silicon, because the applications are so varied. And so NVIDIA is very, very tightly integrated with CUDA. That was one of the questions, right? So you cannot go to the lowest level, to the firmware level, to the assembly program level to optimize your code. Every layer of software that you add is adding inefficiency. So finally, when you go to your top level application, which is built on top of the LLMs, it's extremely inefficient as compared to what the hardware can actually support, because it's one size fits all. So now the need that we see in future is going to be bespoke silicon, which is very, very application specific silicon that is going to get built, and which means that the software that needs to be built has to be very, very closely coupled with the underlying hardware. And in fact, what NVIDIA did was they built the GPU first, and because they got lucky, and then they built the application layer, the CUDA on top of that. But what really needs to happen is software needs to come first. You need to know what kind of performance you need from the underlying silicon, and then the silicon architecture gets defined. So it needs to be reversed right now. And that is the important role that software engineers can really play, and say that this is how I want my performance for this particular application. And every application is different. So for example, from something which is real time, which could be, for example, image processing on a drone, to something which is looking at all the medical records, all the different x-rays, and trying to figure out how to figure out if somebody has cancer, right? So it's going to be heuristic data that can be done offline, right? That's not live data. So every application is different, and for every application you need to squeeze out maximum performance.
So logically, next question for you is that we know that EDA is pulling the semiconductor industry forward, right? So as a person who's seen that and worked in that space, what do you see as that phenomena? And for that phenomena to work exceptionally well here, what kind of talent gaps or capabilities are required as new talent, but also the transition that people have to do from what they're doing, everyone in this room, how to open their minds to the new things which EDA points towards?
Yeah. So first of all, I don't know how many of you know about what is EDA. Okay. So EDA is electronic design automation. So what we do is streamline and automate the process for chip designing. So whatever the applications you are running, right, it has to be on a silicon, and that silicon, we help in designing that silicon. Right? You design the silicon, but we provide the software to them. Right? So coming back to the workloads and the talent and other things, right? So first part is that it's a triangle of processor, interconnect, or networking or memory, right? So what we are seeing from an EDA perspective, right? One, as Sundeep was mentioning, right, the heterogeneous architecture, right? It's not anymore a GPU, right? XPU. It can be a GPU, it can be a TPU, it can be a CPU as well, right? Morning, somebody was giving the example of DeepSeek, right? It was not run on a GPU, right? So it's not about, it's only, the architecture is changing, number one. Second thing, it's memory, right? So memory, typically what happens is that the memory will be kept near to the CPU, so it can be work faster, right? But now for AI workloads, it's more kind of processing in memory or near memory processing, right? So to reduce the latency, bandwidth and everything, right? So memory is in the process itself, right? So that's the second thing we are saying. Third thing is the interconnects, right? Or the high-speed interconnects, right? We are talking about 800 gig Ethernet. We are talking about NVLink, UAL, CXL, right? So we are talking all about low latency, high-speed interconnects, right? So what this mean to the architects, right? So one is, see, you will be seeing a data localization, right? You will be need to think from a heterogeneous architecture, right? Number three, a hardware software co-design, right? For security, right? When you're doing all those things, you should also think about the security layer, right? So with this, all these things, right? From a thought process of designing any software from a CPU performance and memory, you need to design and think from a data flow, right? Data localization, heterogeneous computation, which can do your application across highly complex, interconnected, disaggregated systems. Okay, so that should the way from a architect wise you have to think, right? So that's what we are seeing from an EDA perspective.
So now this is going deep into the core, but Venkatesh, for you the question. We talked about edge intelligence today, okay, the devices, data and so on. And everything is becoming a smart thing at every level. And I think with IoT edge intelligence coming into the home and the digitalized workplace, that is also going to reshape how engineers and architects have to think. So what are some of the pointers in that direction?
Well, engineers have been creating very nice solutions using electronics for a long time. In fact, actually, even before the microprocessor was invented, people are doing great things. We put a man on the moon without a microprocessor chip. Unimaginable today, but they did it. And then control systems happened, garage door openers, washing machines, everything became more prevalent with the introduction of the microprocessor. So we had everything, electronic devices and so on. The next step that happened was that these devices became connected with a Wi-Fi interface or the Bluetooth interface so that you can send data out somewhere else. And then maybe some other system can aggregate data from a lot of sources and maybe take a better decision, managing the energy of a house. So with connected microprocessor solutions, lot of things suddenly took off. The home is becoming highly automated. Smart locks, smart lights, smart appliances, smart blinds. Okay, even for smart wearables. And then in the industrial domain, we have automation for productivity, automation for safety. Everything is being connected. It's amazing what we can do with the, the DigiYatra and the airport and the FASTag and this one. Everything is a connected system. Now, the downside of this is that a tremendous amount of data is being generated. They're all getting pushed to the cloud. And then you need to make sense of the data. You have to do some analysis, and people are lost. They never worked with so much data before. How do you write the mathematical equations to handle all of this data? So they have resorted to machine learning, trying to look at all kinds of the data sets, what people did with them before, and trying to get an algorithm trained with all of those which are properly classified. Now, when you train an algorithm there, the downside is that it still takes a lot of computation power. All of this actually has made energy management a tremendous difficulty, both at the device level and as well as the server level. Okay, now when you do the machine learning, you are still consuming a lot of energy, because whether it is bespoke hardware, which will reduce the GPU energy by a factor of 10 or 100, but still it is high. And then you have the fact that these decisions may not be fast enough, because you have to send the data to the cloud, and then somebody takes things there, we don't even know where the server is, and then the decision comes back. Maybe it's too late. Or that heavy data upload is still going on, and the battery life of edge devices is going to get hit. Okay? And also, suppose there is a disruption in the network. Maybe some critical safety things, okay, cannot take place. Okay? Or maybe some human has done something else. Okay? So you need autonomous intelligence pushed to the edge as part of the whole thing. And that is done because microcontrollers eventually have one ALU, that is one arithmetic operation per cycle. And machine learning cannot work with that. They need hundreds or if not thousands of multiplications, additions, even for the simplest decision. So microcontrollers are changing so that everything has now a hardware accelerator. Just like the servers are getting accelerators, like the GPUs are becoming XPUs, the microprocessors themselves are also getting accelerated with hardware acceleration next to it. So the decisions are now distributed across the server, across the edge, depending on the scenario. So the architects of the entire solution must take into account the fact that certain devices can take autonomous decisions. And how do you pull that in? At the device level also, you need engineers who actually can look at the architecture of the accelerator. Okay, like hardware engineers, system software engineers, maybe firmware engineers, maybe you need acceleraware engineers, okay, to actually know what is the structure of the accelerator and then try to fit the software onto it. So this new structure is what is going to be prevalent, is what's going to, everybody has to think about the distributed intelligence part of it when they are architecting a solution. We see that growing a lot. Okay, one thing is that we spoke about garbage in, garbage out. Long time back it was because people putting garbage in a system, getting garbage out. Now people are not involved. System generates its own data, system analyzes its own data, system takes its own action. Devices, we don't know what kind of garbage they'll do. So all of these have to be factored in making a system scalable, productive, and sensible.
So I think we coined labels for the various kind of people as we went from the simple programmer and the analyst and then so on and so forth to data scientists and everything else. So here there'll be the emergence of new role types, which is something for us to talk about, I think, as we go forward. But clearly, the roles which are emerging for this are new, and we have to think about that. Now, just going in the same logic, the refrigerator also needs now smart capability, right? So this programmable chips is not something just kept for heavy duty AI, ML, billion-dollar applications. So when it has to go to that level, then what kind of skills do the engineers have to start adding to their repertoire?
Yeah. So I think that's a great question for this audience here. Right, so we saw the previous slide, the number of layers. I was not aware. I come from the hardware world and I didn't know that so many layers existed on top of what we built. And the only thought that came to me was that the disconnect between the software folks and the hardware folks is so wide. For us, there's a whole new world out there in the software world, and for the software folks, there's a whole new world which is unexplored below the layers that you deal with. And to squeeze out every ounce of performance. So just imagine if you had direct access to the NVIDIA GPU, no layers in between. How would you code up your software for it? For the application that you're working on. You would need to understand the GPU architecture. You would need to understand how the various GPUs are interconnected. And it's not just one GPU. There are thousands and thousands of them. as Pradeep was also mentioning, it's an interconnected architecture. You have racks on racks of GPUs. By the way, one interesting statistic on the data centers, they're burning so much power that you need cooling systems which are so heavy that your traditional warehouse buildings that house the warehouse, house the servers are not sufficient from the weight capacity. They need to have thicker slabs, thicker foundations. So that's the level of performance that is increasing in the hardware. Now, if you had direct access to that, how efficiently would you be able to code? And that is where the marriage between software and hardware needs to happen, where we are, for the lack of a better term, we are living in the same house, eating breakfast, lunch, and dinner together, and making it work in the most efficient way. And as India is progressing on this journey of Atmanirbharta, what we need to understand is there are companies, which a lot of us now in the industry know about, smaller companies, startups who are building bespoke silicon. And for bespoke silicon, you need bespoke software to be built. And that is where the new skill sets need to be developed, where you are aware of the hardware architecture, the hardware architects are aware of what you're trying to build, and we are trying to integrate both of them so closely that we are building the most efficient systems that are available. As I said, NVIDIA has built one size fits all, and they're doing extremely well. But as we move forward 5 years, 10 years from now, the demand for very, very application specific systems is going to rise. And that is where the talent pool needs to be built. That is where the software engineers need to learn more about the hardware, and hardware engineers need to learn more about the software.
So back to you, naturally, I think you're in that space somewhere, right? So I think this whole silicon level intelligence and business level innovation, bridging this gap, is it going to be a role that bridges the gap, or will there be a big change in the kind of roles which we've had in the past? And I had put a challenge to Venkatesh, please think of some labels, and I think we'll have to work harder on building this. But what do you see as this whole range, and then what does that throw up as a need for talent?
Yeah, just to add on, right, what Sundeep was mentioning about the hardware software, right? So that's the one of the hottest one, right? So what happens is that when you write a software, you are not thinking about what is the underlying hardware, right? You are just writing it, right? So that has to be fundamentally changed. So once you start thinking from that aspect, you will be thinking about the power, you will think about the performance and the memory optimization, right? So that's the first thing. Second thing, we are from the design community, right, who design the chips, right? What we are also seeing is the AI architect and micro architect. So what that mention is basically, see, the architect has to understand the accelerators or what kind of chips they are going to design it, and then accordingly design the silicon using the AI powered EDA tools, right? So EDA also gives tools to them, right? So use the EDA tools to maximize the productivity and come up with a efficient architecture which will power performance and area, right, when it comes to silicon. Now, third one is, again, goes back to the NPU and the TPU software engineers, right? So there are multiple, new things, roles we are seeing in the market, right? One is basically they want to design a better debugger frameworks, compiler frameworks, right? And optimize the model on-demand deployment, right? And another one is intelligence of your whatever the applications you are running, make it near to the data, right? So that's another one, right? So these are not all the traditional roles what you see in the industry, right? So this requires a change from as I was mentioning, right? It's not available now. It's an interdisciplinary roles, right? So first there should be a fundamental change from how our courses are then in engineering colleges, right? Graduation and post graduation itself. That is number one. Second, an industry academia collaboration, right? At least we are seeing something here in India now, but that is something need to be improved, right? And third one is specializations, right? Specialization certifications, workshops, right? So it's required a paradigm shift in multiple aspects to get to this one, right? So that's where I think, NIIT kind of institutions, right, can help and bridge the gap. Right? It's not more anymore an architect, right? It can be a solution architect, it can be a system architect. It goes, the chain is increasing. Right?
Good. So I think in this session I did want to leave time for questions because it's a new topic. And you guys have done better than I expected. We thought we should be at 15 minutes. We have 19 minutes. Okay. Is that correct? It's showing 19 minutes by the clock? Is that right? Great. So thanks so much. I think you guys have covered a very vast range of things, and I'm sure you've created more questions in this topic than others. So we have time. So whoever wants to start, please, if you can. Mike can come. Yeah. Just identify yourself and your company so that any of those have an idea. So one thing I want to say, this trouble we all have with the mic is a global phenomenon. Is waiting for some startup to build $1 billion industry that you give him and he speaks and it works. Unsolved problem. Is better. Unsolved problem. Yeah, please go ahead.
Hey, this is Arnab.
Yeah, go ahead.
I am Arnab from Morgan Stanley. Very thought-provoking conversation today. What I want to ask you is slightly unrelated to this, but I think earlier in the day we heard Dr. Pramod talk about, talk about the exponential effect we had, and we kind of leapfrogged a lot of other advanced companies when we did the software revolution in India. Do we have a similar situation, or do we have that, since we are starting the silicon journey today, do you see us getting into quantum? Do you see work happening in that space on quantum compute, and do you see that opportunity for leapfrogging the other nations and getting into that space?
Yeah, we are in nascent stages, but there are startups in India who are working on quantum computing. The government has also announced a quantum mission, but it's not to the level where the West is today, or maybe China is today. But we are starting that journey, and it will take time, but there are startups who are working on this. That's a very, very preliminary level, I would say. We are like just in the birthing phases of quantum right now.
Those of you who are particularly interested to get a view of that, in NASSCOM we have a deep tech club. I think what we are seeing, the work we are seeing there is actually quite astonishing. So when people like Pramod talk about 10x increase in startups, it is happening, truly speaking, at a pace which is not visible yet. It's truly not visible yet. But I heard Pedigree talk about the fact that how does the startup think about this, that and the other. So when we say, is it all human skills? It may not be, maybe agentic skills, right? So I think they have an ability to weave together things and take for granted, because of which we will probably see an acceleration in these areas. You want to add in?
Yeah, from a software or the EDA ecosystem, right? So we have the right ingredients are there. So the ecosystem has to be built to take forward. So we're at the early stage. All ingredients are there, right? Right intent is there, vision is there, strategy is there. It's now execution phase. That's just we started it.
Like DeepSeek, okay, they spoke about all the mathematicians they used. Many of these new technologies, okay, the quantum, we are at the ground floor right now. Lot of steps to climb, but it's deep core hard tech. We need engineers who understand physics, quantum. Even Einstein could not understand quantum effects properly. We need people who are deep physicists and mathematicians if we have to make fundamentally new things. And luckily, the whole world is at the same place right now. So we have a chance if we are willing to work hard in that area.
So I tend to feel that when we look at why did China do it so quickly, and can we do it that quickly? To me, I think a lot has to do with how ancient the civilization is. Don't underestimate that 7,000 years of our civilization. China's a little less, so we keep competing. Of course, they have a method of governance which gives them speed. Right? That's what they had. We have meandering along democracy which doesn't reverse with a shock, but comes a little slower. So it's not a surprise if we say that 20% of all engineers come from this part of the world. and we have population as an example. We have, I think, a lot of energy in youth as an example. It's a very vibrant kind of thing. So to me, when we see that in NASSCOM, we're getting shocked by the amount of brilliance coming out of these startups, as we are seeing, and Pramod talks about 10x or whatever, and you're all pointing to the fact that even in the facility that GCCs are moving that part of the work here. If not, it moved a long way from programming or BPO into deeper stuff, coming all the way to saying, okay, let's go where the source is. Now, as our own semiconductor phenomena begins, and India not just as a market but as a source of talent, when these two match, then I think the growth will be quite phenomenal. So I think it's a question really of time. Thanks for the question. Take the next one. Yeah, please go ahead.
Hi, I'm Sunil. I'm coming as a senior architect from elsewhere. See, I would like to share an analogy of a building architect and civil engineer.
Is your mic on or $1 billion business?
Okay.
Keep it horizontal. Yeah.
Okay.
Yeah.
So I'll take an analogy of a building architect and a civil engineer. Building architect don't bother about what is the internal structure of a stone or a alloy which is used in a gate, etc. Similarly, I always have been saying I don't need to know hardware that much. But today what I'm hearing is, no, I need to know. But I'm still not able to convince myself that really I need to know the details. Why can't the platforming concept really become more like consumable? Instead of like me trying to understand all the details, it will be overkill because software engineers and architects are overloaded by their own complexity. I mean, why do we, can you make it easy for us to understand?
We want to make it a little bit more difficult. The thing is that, okay,
just for entertainment.
Let's say that, okay, you are in the, you have a lot of thoughts in writing software which can help, for example, drug discovery. Okay, now introducing a new drug in the market in the US is $3 billion. A lot of tests that happens. Okay, can you actually run a simulation of an organ on a server so that it can react the way your proposed drug molecules are reacting? So how do you do that? So if you want to use an NVIDIA GPU for doing that, you will need to, maybe get $100K worth of GPU every week. Can you afford that? On the other hand, there are other companies which are actually bringing specific hardware for the kind of functions that you might use in drug discovery. So you, as a analyst in that particular area, know what functions you use most. And then you are getting the hardware built for you. Now you know so you are at a position where you are able to create greater efficiency. So not everybody needs to do it, but some people have to do it for the industry to become more efficient and really support a lot of new workflows that are going to come. Some people have to do it.
So this is the conversation. I think this is the conversation which has to start, that this is what I need, and then on the other side, this is what we can do. And so the deep seek example is exactly of defining a context. Rather than saying my system will do everything, you say for this, do it in a fraction of the cost. So the more this dialogue, two-way dialogue happens, and you start defining this is what I need, then from this side they can say, okay, there are 100 things I'll remove because I'll do for you what you want with less power, very, very important, much lower cost and higher speed. So I think that's the conversation.
Yeah, so I just want to add one more point. So that's a very good question. So I'll just give you an example. Today an NVIDIA Blackwell GPU, 1 unit, do you know how much it costs? 1 unit. $40,000. Close to that, right? And to have an AI server platform, a full warehouse, how many GPUs do you need? You need hundreds of thousands of GPUs. So you can imagine the cost structure, right? And people are using AI for a lot of useless stuff like Ghibli images and stuff, right? But for all the real use cases, right? There is immense amount of GPU power that is required, immense number of GPUs that are required. Now people all over the world, not just in India, but all over the world, people see this as an opportunity. It's a $1 trillion opportunity. NVIDIA valuation is $4 trillion today. People are building specific XPUs which are tuned for matrix multiplication. And now, on top of that, we are building software. Those companies are hiring software engineers. We are talking about a new class of engineers, new class of software engineers who are building software on top of these new XPUs, which are squeezing out every drop of performance to sell that at a fraction of the cost, which would be, let's say, $7,000 or $8,000. So now if I'm a drug company, for the example that Venkatesh gave, and if my application is only drug discovery, I will buy that for purpose built software and hardware, and I'll deploy 100,000 XPUs versus $30,000 or $40,000 GPUs from NVIDIA. So that is where the market opportunity is. So we're not talking that every software engineer needs to know this. We're talking about a new class of engineers that need to be built who understand the whole stack.
There's a question there.
All right, I'm really sorry, Rajiv, but I'll have
I
to
have
come
8
in.
minutes 48 seconds by your clock.
Yes, and there is
By
a
your
gentleman
clock.
who's been dying to ask a question, so hence I have to
Focus
step
on him
in.
and then that's the last one.
All
I
right.
have 8 minutes 39 seconds, so go ahead.
I'm Ashutosh, I'm from HFCL, and I thought this is an opportunity to ask because just like your silicon hardware people are also rare to find nowadays. Whenever we are going to conferences, we have all application developers. So my question is that we do product development in the networking space, and we are trying to work upon using some sort of models onto our platforms, right? Rather than relying on some sort of GPUs running somewhere in the cloud. What is the direction you see towards using some sort of models for intelligence at that level?
What was the application you said?
Network, telecom equipment.
Okay.
But when you say models, what do you mean?
It could be a small language model, some sort of a language model to build some intelligence at that layer, at that level.
Yeah, people are actually, thinking a lot about that because networking, okay, is getting packets across at most efficient way using the minimum amount of resources and ensuring a certain quality of service to people. And people are using a lot of, AI-driven convergence of what's the best configuration you can do. Okay, those are all algorithms people use to make the user experience better than before. They are currently, they don't process, millions of data sets. The amount of data is fairly limited. So the amount of processing power today in the routers or in the network nodes are sufficient. But it's a new way of thinking about how you can make the user experience better for people. It's certainly something in progress, not only in the physical networking, but also in the wireless networking today.
Last question. I just noticed that the watch, either my watch is going faster or we still have 6 minutes, or that's going slower. So last minute, that last we'll close. I think we are beyond time.
His quiz took longer.
So the audience is very slow.
I'm trying to think that the conversation is going really well.
Okay, last question.
Hi, Siddharth here. I am from Maxtria. So this is interesting for me because I come from electronics background and I am in software for more than a decade. Right?
Traitor.
So, yeah, in fact you can say that, but for my own. So my question is mainly on if we are going through this electronics and chips and sort of stuff, right? We talked about China, we talked about DeepSeek as well. Now China is doing a Canton Fair in the next 2-3 months, like in September, October, November sort of thing. But it's not happening in India where most of the people are aware of it, or what exactly is happening in terms of semiconductors, chips and other stuff. In Canton Fair, let's say there are 3 phases where one of the phases is mainly on the electronics exhibition sort of thing. But it's just a thought that I am putting, not a question. Is there something that you can throw some light and any idea on that?
Semicon happening?
There are a number of conferences that keep happening for the semiconductor industry. Yeah. Now the biggest one which is going to happen September 2nd, 3rd and 4th is called Semicon India, which is happening in Delhi. So that's a very big conference, but it is more focused towards manufacturing rather than chip design per se. IESA, which I am a part of, which we all are part of actually, which is the India Electronic and Semiconductor Association, has a yearly conference called the Vision Summit, where we talk about all the companies which are developing chips in the industry. So it is, there are a lot of conferences that happen, which is very focused, but yes, the level level of conferences probably that China does, I have never attended one, I don't know if you all have, is probably very different.
The VLSI design conference is there.
September, right?
September.
We have a design and verification conference in Bangalore in September, okay, which is also about the semicon industry. Every year there is an annual conference called VLSI Design that's been going on. See, the first conference I attended was 1992. Every year it's been happening. This year it was in Bangalore, next year it is in January, it is in Pune. Okay, so we do get together in many of these and we see firsthand a lot of things that are happening.
Ask GPT for all the conferences which are there for the subject you want. Get an answer.
Or you can also look at India Electronics and Semiconductor Association. Sundeep is one of the governing body members there, IESA. Okay, then you can go to their website and it will list a lot of information.